Hey guys, we're going to start figuring out and learning about how batteries work, which are a little bit complicated, but we're going to try and simplify how they work in this video. Okay, so up on my board here, what you can see is I've got a chemical reaction, right? We have hydrogen ions gaining two electrons, becoming H2. Now, this is a pretty important reaction. It's obviously pretty common or pretty doable because hydrogen ions, we know that we have lots of hydrogen ions in our solutions. And turns out that hydrogen, when it gains two electrons, this is kind of a standard reaction that we use, okay? And what we can do is we can say, okay, well, first off, hydrogen is gaining electrons. So if it's gaining electrons, that's going to be reduction, right? So again, we know Leo goes Gur. So we know losing electrons is oxidation. Gaining electrons, as we've done up here, is going to be a reduction. Okay? And all of our chemical reactions or reductions are referenced to this point. So we're going to say that our electron potential, E naught, is going to be equal to 0 volts. We're just going to say that this is the 0 point, okay? And so hopefully you can see that. So this is where our way to quantify how much a species, an ion or a metal, whatever it is, how much it wants those electrons. So hydrogen is kind of a convenient in-between middle point, so we're going to call it 0. All right, but hydrogen really isn't that useful in batteries, so far at least. So oftentimes we use metals. So let's use one of those metals. Let's show what happens. Let's do copper 2 plus 2 electrons can go to copper 0. Again, this is going to be a reduction because copper is gaining electrons, and it kind of wants the electrons more than hydrogen does. Okay, so this E naught, the electron potential, how much it wants those electrons, is going to be positive 0.34 volts. Okay? Then let's look at one more. Again, as I said, we like to use we like metals a whole lot more generally in our batteries, and so let's look at silver. Silver, Ag plus, could gain one electron and become Ag0. Now, or silver metal. Now, obviously, we're not going to want to put silver in our batteries because silver's kind of expensive, but silver actually wants those electrons even more than copper does. So the E naught here is going to be equal to 0.80. Okay? So it wants those electrons even more than copper does. So what we're going to do is we're going to start constructing a electrochemical cell. So this would be our electrochemical cell here, and we've got a few different pieces to it, okay? First off, we've got one solution over here, one solution over here, okay? In each of those solutions, we've got a metal piece that's put in. So this would be either silver or it would be copper. The other one would be silver or copper over here. Then we're connecting those with a wire, okay? But we also need to be able to have some of the ions in solution to be able to move side to side. So we've got what's called a salt bridge here. This salt bridge lets those maybe nitrate ions or potassium ions or something small like that move between the solutions so that they don't become charged, because that's impossible. Okay? Overall, our solution has to have a 0 charge. So what we can say is we have a silver metal silver ions that really want to have silver, or they really want to have those electrons and become silver. So it's going to want to do that more than copper does. So what we're going to end up having is this will be our reduction. okay? This will be our reduction reaction, all right? Since it's reduction, I'm going to put it on the red side, and we're going to have this be silver, all right? And we're going to have silver ions in solution, okay? I'm going to call this side the cathode. The cathode, how am I going to remember that? Well, I have a red cat. So I'm going to say that I have a red cat. Now what's this other side? This other side, I'm going to have my copper and my copper 2 plus, copper and copper 2 plus. We've actually seen a blue copper 2 plus solution in the lab before. And so on this side, right, silver wants to gain those electrons more than copper does. So copper is actually going to be flipped. We're going to have our reaction going the opposite way. Okay? So copper, our metal copper here, is going to be losing electrons. And they're going to be traveling this way over to silver, where silver ions can be gaining those electrons. Okay? So on this side, this is going to be called the anode, right? Where the copper is losing electrons, it is the anode. So this one, if we're going from copper to copper 2 plus, it's losing electrons. Losing electrons is oxidation. So I have a red cat and an ox watching, watching Leo go grr. All right, so our whole phrase now is right here. I can say I have an ox and a red cat watching Leo go grr. Anode, oxidation, copper is losing electrons, so it's an oxidation. Anode, losing electrons, oxidation at the anode. Anox, watching a red cat. Silver is gaining an electron, so this is going to be the cathode, and it is a reduction. Okay, so we have our anode, we have our cathode, we have a salt bridge, and then we have a wire that connects our two metals. Okay, I think that is all of our pieces of our electrochemical cell. We have our whole phrase here that tells us all about what is happening with this reaction. And we have electrons, we know which way they are flowing because of our electron potential values, okay, our reduction potential values. So this number here, right, is larger than this number. So this silver wants to gain that electron more than the copper did. So that means that silver is the cathode. So overall, how much energy am I going to get out of this reaction? I would need to start from my cathode. I'm going to do the E naught value of the cathode minus the E naught value of the anode. So 0.8 minus 0.34, I should get 0.46. Okay, so 0.8 minus 0.34, and I get 0.46. So in this reaction, overall, I'm going to have a charge moving of 0.46 volts. Okay, hopefully this helps you guys a little bit.